Welcome to Key Shop. Today I'm going to talk about how I made these vases and go through the various steps of that. The first one I did is out of ash and walnut and has a very interesting look to it. And then the second one I have is out of birch and walnut. And this really has a different look to it as you rotate it, that the light plays off the different segments of this. So with that, I hope you enjoy the video as we go through the steps.
I would like to acknowledge Jerry Bennett's YouTube site that discusses the Wedgie sled, and it's a very simple sled that allows you to cut the wedges for the segments on the vase. You can find it by just searching through for segmentology on YouTube. And there's a handful of other wood turning video channels that I have found useful. Carl Jacobson, Gord Rock, Wyoming Wood Turner, Stephen Ogle, and Tommy Akeridge. And there's a few others too. And one thing that I will emphasize on this video that I'm recording, I'm not going to be showing actually turning on the lathe. You can find a wealth of information from both these video channels as well as others on techniques for turning. Plus, I'm not really set up easily to record it in my shop for that. I'm going to concentrate mostly on the design of it, and I'll show you the step-by-step process that I did, but just not actual turning. The vase data, here's some pieces of information that I think you'll find useful on that. I used two different types of wood for the vases. I used ash and walnut or birch and walnut, and both have some pretty significant different effects on looking how it's displayed on the vase itself. I used 12 segments per layer. Turns out to be 30-degree wedges for putting it together, and I used the same whether it had contained the feature wedge, actually 2 of them per layer on 14 of the layers. 18 layers total for these segmented rings, and the finished size is roughly about 12 inches tall. There's total 341 individual pieces in the vase itself, and I built it into 2 halves. I finished the inside, then I attached the 2 halves and finished the outside, and it roughly took me about 40 hours per vase. The first step is making this was trying to figure out what I wanted to make. So I sketched the shape of the vase, and that included both the inside and the outside profile, so I could get some measurements off of that for determining the radius or the diameter, both inside and outside at each of the segments, or at the segment boundaries also. Then I used this data to calculate the wedge sizes based on the calculator diagram, and we'll talk about that one next, and that'll determine both the wedge length and the wedge width of each of these pieces here. This is my sketch of what the vase will look like, and I've broken it down into the 18 different layers or rings, and I've labeled them over here on the right hand side. And I've drawn both the inside profile and the outside profile, and then measured on the quad paper the inside diameter and the outside diameter. And I use these numbers then to calculate for going in to calculate the wedge sizes. You also notice here I've got just a note on here on the extra tenon. I have an extra layer in here that I used for the tenon that will connect the top and the bottom half together to register them. Once I've drawn the basic shape up, then I need to take note of each of the segmented or ring sections, what the inside and the outside dimensions are going to be so I can calculate the thickness of the wedge or the wedges at that layer. And you need to take into account the two boundary numbers. In this case, on the inside, I want the smaller of the two numbers. So in this case, I have 3.5 and 4.5 inches, and I want to take the minimum of that. Then on the outside, at the boundary of that ring, I want to take the maximum for the outside diameter. So in this case, it's 4 3/4 and 5 3/8, I think that is. And so I want to take the maximum number for there. And then so that's going to give me a block that's going to contain both the inside and the outside diameter. And I found this website on to try to put together the segments or the staves, and this was for, I think, a drum assembly, but it gives a nice drawing. Then I added a few pieces for this. Again, 12 different segments in the ring, and it's 30 degrees per segment, or each of the ring ends is going to be half that, so it'd be 15 degrees cutting for each of the ends of the wedge here. And on the inside radius, I want to take from the center to the inside of this curve here, or the angle here between the wedges. And so not this dimension here, but up here at the intersection. And for the outside radius, I want to take the minimum radius here, which is actually going to be on the flat piece, not up at the corner. There will be extra waste at the corner. So I take this dimension here on the flat piece. So that's going to be the inside and the outside dimension for the minimum width of a wedge to cover the thickness of the vase itself. And I typically was trying to shoot for about 3/8 of an inch wall thickness on the vase. I know a number of turners who are experts at this tend to go thinner than that, but I didn't on these first few, didn't want to take a risk on that, and I thought 3/8 of an inch final thickness was a reasonable amount there. Being new to turning segmented bowls or vases, I was always a little confused as to how to calculate the width and the length of the wedges to cut. And I ran across this example, and I can't remember the name of the YouTube video that I watched, and it showed how to use a diagram like this for calculating the wedge sizes. It was a little confusing to me, so I thought I'd actually take some time to explain how I used it, and hopefully that will help explain it to you if you haven't seen this before. It involves drawing a triangle here, and the separation of the triangle, that is the angle from one side to the other, is 30 degrees, and in that case it corresponds to a 12-piece segmented ring. If you have different segments like 8 or 16, you're going to need to draw a different size triangle with a different angle on it. I also have numbers here corresponded to each of the horizontal lines coming down. These are going to be inches, so that'll be 1 inch, 2 inch, 3 inch, 4 inch. They're separated by a ½ inch, what normally would be a 1/4 inch on the quad chart here, but remember we're dealing with diameter here, not radius, so that's why there's a factor of 2 here. And down the other diagonal here of the outside edge of the triangle on the left side is the inside diameter, and that's actually, I just took a ruler and measured down the diagonal here, and once you get a little bit longer you start getting a separation between the 7-inch mark on the horizontal line with down the edge line. So I'll use those two sets of numbers for calculating where the wedge edges should be. In the example I have here, I've taken the inside diameter example of 5.5 inches. So again, halfway between the 5 and the 6 down the diagonal, and I've drawn a orange dashed line here. On the outside diameter, I've used 6 inches, so that's down the center line. 6 inches will be here. Again, I drew another orange dashed line here. So that's the minimum size of the wedge for the finished piece that I'm going to need to be building. And I'm assuming a 3/8 inch diameter wall. In this case, it's going to be 3/4 because it's twice of it as we're looking at the diameter. So I'm going to want my wedge to be a little thicker than that on the high side as well as on the low side. So in this case, I added about 1/4 inch thickness to the outside edge for that and drew a red line here. Then I also did, I don't know, I may have done 1/2 inch or so on the bottom side just to be safe, and drew another red line. So the outline of the red line here, the side of the triangle, the red line here, and the side of the triangle here, that's actually the shape of the wedge for the segmented ring that I'll do. So I'll need 12 of those wedges in there. Now to calculate the length of the wedge, I'm going to take the outside line here, red line here, and the difference between the right side and the left side of the triangle, that's actually the length of the wedge. In this case, that's 1 11/16 inches. And in this direction, I know it gets a little confusing, but that's actually 1/4 inch increments because that's a true length there on that. And the width of the wedge is going to be 1.5 inches. Again, from here to here is 1/2 inch, 1 inch, 1.5 inches. So that gives me the size of the wedges. Now, just to save some time, I've calculated the distance between the left triangle and the right triangle for each of the horizontal lines on the quad sheet here, and I recorded those distances over here on the right. That gives me a quick indicator. Now I don't have to go back and remeasure it each time. So I need to go through and calculate this for each of the rings that will go in the segmented vase that I've done here. In this case, 18 of them for the vase that I'm making here. I hope that helps explain things a little bit more if you haven't seen that before, and that you found it useful. Okay, so once I've calculated the wedge width and length, I record it on a sheet like this, and I actually started with the sheet on the left side of it. The left column is the layer number 1 through 18, 18 being the top actually at the bottom of this list, and 1 being the bottom or the top of this list. The wood type for each of the layers, so they're all birch except for the top, or in this case the bottom layer and the top layer are walnut. The finished outside diameter and inside diameter for each of the ring segments, so I record those numbers down. So then I take these numbers, go into the wedge calculator which I just showed you, and then I can calculate the wedge width and length for each of the segments within the ring itself. I use 3/4 inch thickness for all the rings with the exception of the bottom 2 rings. The walnut and the first birch one are 1/2 inch, and likewise the top ring, the walnut one is 1/2 inch, and then the first birch one is 1/2 inch. I also have the extra tenon ring that I'm going to put in here, and that's what I'll turn down to make the tenon that will attach the 2 halves of the bowl together, or the vase together. And I actually ended up using 3/8 for that. I made it 3/4 to start with and then just turned it down. I also can take a number of the similar widths to make the stock as I'm preparing the stock. Like you notice there's quite a few 1.5 inches. It just makes milling the lumber to prepare it much easier if I have general uniform widths on that. And here's the Wedgie sled that I put together for the cutting the wedges. Again, I used Jerry Bennett's Wedgie sled design. You can search for segmentology on YouTube to find the videos for it. They're very self-explanatory in how to use it and actually how to build the sled. You can download for free the plans for it. I extended the width between the two fences a little bit more in case I want to do a little bit wider wedges for this. It has an upper fence and a lower fence, both held by knobs here, and I built the ramp that attaches to my zero clearance insert on the table saw to help keep the wedges away from the blade after they're cut. And I built an adjustable stop here that allows me to cut uniform wedge lengths then for this. I was a little concerned about cutting with the blade so exposed on this, particularly as the wedge stock gets shorter and shorter. So I actually designed and built a guard for this, and that's shown right here. It just fastens down underneath the inner knobs by the blade, and it's made of 1/4 inch polycarbonate, and I just use scrap for it, and it does a pretty good job of also collecting dust. I added a 3-inch dust port to this. I have a separate video for this on my shop channel for how I built this, and you can take it on and off very easily. You can adjust the angles of the fences without removing the guard, and it just gives me a little better peace of mind for cutting the wedges. It also has clearance through the back side of the guard to the adjustable stop for setting up the uniform lengths of the wedges. You also have a clear view down through the top, so you can see exactly where the blade is cutting when you're setting up some of your cuts. And here's an example of the one of the rings I put together. This doesn't have any feature segments in it. This is actually the top ring with all walnut here. And the wedge sled worked just fantastic for cutting these wedges in uniform angle, and gave me uniform length and width for that. And here's another one, and this one I used for ash. Again, no feature rings. These are 1/2 inch thick that goes for the second layer down from the top. And I've shown a block of that I'll use for the feature. I'll use 2 of these for each ring when I get to the feature rings, and I'll talk about those next, how I made those. This is the cross assembly blocks that I'll show you how I made those, and it's actually pretty straightforward. I took 2 birch blocks and cut a slot in them. And cutting the slot was a bit problematic. First I tried using my table saw, and on my table saw with the fence I have very good adjustment of the fence, which would be the up and down direction here on the block itself. But the adjustment for my table saw height, it's hard to adjust and it's hard to lock it in place. The third problem with it is the A.K.A. blade that I'm using, alternate tooth bevel, I think it stands for blade, and it doesn't leave a square bottom for it. I then remembered that I purchased a slot cutter for my router table a few years ago, and pulled that out and used that, and it worked great. I have very fine adjustment for the fence, which is the same as on the table saw, up and down, but I also have very fine adjustment on the height of the slot cutter, so getting a uniform depth of cut was very easy. Plus it has flat bottom cutters on it, and so it worked very easy. I set it up to cut actually like 4 blocks at once because it's easier to work with a bigger piece of wood than the small blocks. And then I also cut walnut filler pieces to go in these slots for the cross sections, and cut a filler piece which gets rotated 90 degrees and goes between the 2 blocks then and gluing it together. The one thing that I would have done different is I made the vertical piece a little bit longer so I could then sand it down and get it really nice, but it was hard to get really fine alignment of the blocks lining up with each other, and I had a few of them I had to discard because the cross pieces weren't aligned one to the other. So once you get it all glued up, then I cut the end off, and this is what it looks like. So it's very good. One thing you'll notice is on the birch, it's the grain is running horizontally here, but the grain on the walnut inserts is going down the length of the block, so you have end grain here. And I actually wanted that on purpose because I wanted the end grain to really soak up the finish and be darker than it would be if it was face grain, to really stick out, and worked out very well for that. So here's a completed block here, and then I will cut this into 4 smaller blocks for making up the feature segments on the rings. This is it's a 3-wing cutter, slot cutter that I purchased a few years ago from mlcswoodworking.com, and I used the 1/8 inch slot cutter for this. And if you order this number here, it looks like it comes with both the cutter as well as the arbor and the bearing, and it works out very well for me. The next step then is to take the wedge stock where I had prepared before based on the width of the wedges for a particular ring, and add the 2 of the feature segments to it, and then I can start cutting them up. Now the first go around on gluing the feature blocks to the end of the wedge piece, first of all, the reason I did that is because the blocks are too small to adequately control and cut the desired angles on them for the wedges. So I wanted to give a little bit more length for working on that. So I tried just doing a friction fit using yellow glue to glue them onto the wedge stock one at a time by placing them up against a reference guide, and that just really didn't work. They didn't give me a very good glue joint, and they were fragile. You bump them and they came off. So I found out a better way to do it is to actually use hot glue, and that worked out fantastic. So I take my wedge stock, put it up against just a reference piece of wood here, straight piece of wood, and then add some hot glue to the end of the first block, press it up again tightly against the wedge stock as well as the fence, let it sit to harden there a little bit, and then do the same thing for the second feature block also, and let that cure. That way now I can, on the wedgie sled, I can go ahead and cut the wedges with confidence that they're not going to go flying all over the place, and I can hold them very steadily for doing that. Now, cutting the wedges, if you don't have feature rings, it's actually pretty straightforward. You just cut a nice clean edge at the right angle at the end of the wedge stock, and then you alternate between the fences. And again, Jerry's website has great description on how to do that. Cutting it with the feature blocks requires a little bit more thinking and a little extra step. In this case, I've drawn the anticipated cut lines in dotted lines here for the first one and for the second one here, and the length between those lines on the outside edge is going to be the length of the wedge, and the width of the wedge stock is going to be the width of the wedge. So we just need to set those up and cut them. And I've gone through a cutting list here of how to do this, and the more I thought about it is I took a little time to actually go through and do the example of how you would cut it, because you don't just alternate between the fences here on the Wedgie sled to do that. So with that, let's go through the examples here. So again, the Wedgie sled is shown here with the upper fence and the lower fence. The first thing I did is mark where the blade cuts are going to be for the outside edge on the feature blocks. So that's the first thing I did. The other thing is that Jerry suggests doing is taking a pencil and squiggling a line on one of the sides of the top side of the wedge stock, as well as one of the edges for it, and that always remains on top then, no matter which fence you're cutting from. So that's the first thing I did. I marked the edges on that for both the feature blocks here. I then aligned the stock here so it's going to cut on the left side of the blade, and I went ahead and made that first cut. Then I went and aligned the block so it's going to cut on the right side of the blade, and so that will be the wedge length, and so I aligned that there. Then I brought the stop up while I'm holding the wedge stock firmly against the upper fence so it's not going to move. Bring the stop up, lock it in place. Then I actually just reset the wood just to make sure that they're all going to be the same up against that stop block. Then I go ahead and make the second cut here. So that's going to give me my first feature segment on the ring. Then I come down and repeat just like I did on the first one, where I had marked where the angle was on the second block, left of the blade, and I make that cut. Then this time I don't have to align it to the blade. We have the stop in place. So I just move the stock to the right up against the stop, hold it in place, and cut the second feature segment there. Now, normally then you would just alternate between the fences once you get rolling here on this, but remember that I actually cut two wedges the same orientation. So now I have to cut two plain wedges the opposite orientation, because you want the same number of each orientation, so any minor imperfections, they balance themselves out when you go to glue it up. So the next stop is, after I cut this, the next stop is I leave it on that same fence and I cut just a clean edge on it for cutting the first plain wedge. And I cut that. Then I move it down here. Again, we still have the stop set, so I run the wood up against the stop and then make the first cut on the first plain wedge. Then again, once we get rolling, you would just alternate fences, but in this case I have to cut two of those other orientations of the wedges so they balance out. So I come up here and cut a clean cut up here at the top. I don't run it up against the stop. I just cut enough to cut a clean edge there. Then I run it up against the stop and cut the clean edge here. Now, from this point on, we just alternate fences by moving the stock up against the stop each time. So for the next one, run it up against the stop, make the cut, run it up against the stop, make the cut, and you just keep alternating back and forth till you've cut the 12 segments for that particular ring out. And that's as simple as cutting these go, and hopefully that pictorial example was a lot better than the words on that one page there. And that's the end of part one for designing the vase and cutting all the wedges for it and for each of the rings. Next we'll get in part two how to glue the rings up, and then put the rings together for turning the vase. I thank you for watching and look for part 2.